Okay, this is question 2 from the free response packet that I graded. So this is the picture that you have, and you would have a calculator for this. So if you were not sure which one of these functions is ln x, you can always graph it on your calculator and you can see, but it's this one over here. And the other one is going to be y equals 5 minus x. And part A is asking you for the area. So for the area of this, you should be doing top minus bottom. And the picture is going from 1 to 5. But the problem with this is that, I'll do this in different colors, ln of x is the top until it gets to over there. And then 5 minus x is the top over here. So what you want to do is figure out where are these functions intersecting. So you have your calculator. So two ways you can do this. Under y1 you can put ln x. Under y2 you can put in 5 minus x. Go into second calc and then choose intersect and figure out where they intersect. Or you can set them equal to each other. Sorry, I just totally screwed that up. And then get it set equal to 0. And then you can put that in your calculator under y1, and then you can go into second calc and choose the one that says 0 and see where it hits the x-axis. Okay, so in either case, no matter how you do that, you're going to find that it intersects at, keep in suspense while I'm erasing, it's going to intersect right here, and that x value is 3.693. Okay? So the first function is going to go from 1 to 3.693, and it's going to be the top minus the bottom. Now the bottom is just this, y equals 0. So you don't even have to bother writing anything for that. Okay, and then to that we're going to go from 3.693 to 5, and now 5 minus x is on the top and 0 is on the bottom. Okay, so you're going to use your calculator, and this will come out to 2.1317. This one will come out to 0.8541, and your total is 2.9858. Okay, also you could do this as a right minus left if you don't want to do the point of intersection. Then you would do 5 minus x minus ln x, and then you would have to find the y values. So the lowest y value would be 0, and then you would need this y value up here, which you could get by taking the x value, this x value, and putting it into the function, and you'd find out y. Okay, so that's it for part A. So now we're up to part B. Okay, so we have the same picture. Okay, so for part B, this is area of cross-section, so immediately here's my integral area of cross-section, and it's saying it's perpendicular to the x-axis, so that means everything is going to be in terms of x. If I could get this thing to work. Okay, so what is the area of the cross-section? Well, this would be the height over here, but over here this would be the height. So again, we're going to have to break this into two separate functions, and that's fine. So we're going to have one that's going from 1 to 0.3693 of the area of the cross-section, plus the other integral from 3.693 to 5 of the area of the cross-section. Okay, so what is the cross-section? It's saying that it is a square. So side squared is the area. Okay, so what will the side be? The side is going to be, I need another color here. So until we get to the 3.693, a side's going to be this like turquoise blue line. So what is the height of that line? It's the top function, which is ln x, minus the bottom function, which is just y equals 0. So it's just going to be ln x squared. Okay, and now for the other one, it's also side squared. But now the area, the side is going to be that line right there. So that is going to be the 5 minus x minus y equals 0. Okay, so 5 minus x minus 0 is just 5 minus x, all squared. So now I know the area of the cross section for this one is ln of x squared, and the area of this one is 5 minus x squared. Okay, and the question is saying write but do not evaluate an expression involving one or more integrals, so you can feel completely comfortable giving two integrals, and that would be your answer for part B. You're not solving that. I mean, you have a calculator and you could, but do not waste time doing that. Okay, let's go to part C. Let's go back to the picture again. Okay. There's a horizontal line y equals k. So let's say this is the line y equals k. And it is going to divide R into two regions of equal area. We did a problem like this in class the other day, and we weren't sure if it was of equal area. Okay, so first of all, we already solved the area in part A. And in part A, we found that the area is 2.9858. So if you divide that by 2, then you will get 1.4929. So that means that this piece in here should be 1.4929, and this piece in here should be 1.4929. And what you have to figure out is where should you place that line y equals k so that it will be equal. And we just have to set this up. We're not solving anything. Okay, so our function is now actually, our area, we can do this one and do top minus bottom, which would be the k minus 0. That would make no sense to do that, right? Or we could do this top part here minus the bottom, and this part minus the bottom, and find the point of intersection. Yeah, so you have a bunch of different things to think about here. However, okay, sorry, I think I had to stop for a minute. I think I stopped in mid-sentence. Okay, if I do top minus bottom of this piece up here, then I'm going to have to use the intersecting pieces, and it's going to be the top minus k, and this could be a problem. Could we do it that way? Probably, but I think it might get a little out of hand. So what if instead we do a right minus left instead? So I'm just going to redraw this picture a little bit because it's looking very messy. Okay, so if I want to do right minus left, then we're talking about dy. So here, I'll erase as we go. So right minus left, dy. And that means that my limits here are in terms of y. So the smallest y value that you see is 0, and the biggest y value will be k, because we're going to look for this section right here. Okay? So far, so good. All right, so we have from 0 to k. The function on the right is going to be, running out of colors, this part right here. And that is 5 minus. That is the line y equals 5 minus x. But I'm not allowed to write 5 minus x here because I'm going to have a dy. So I'm going to have to change that around. So if I know that y equals 5 minus x, I can bring the x over and get y plus x equals 5, and then x equals 5 minus y. So that's the right one. Minus, okay, the left one was y equals ln x, and I need to solve for x. So I'm going to add a base of e to both, and I'm going to get e to the y equals x. Okay, so this is my setup, and this needs to equal 1.4929, and that was the answer. So you go back to the question, make sure that you answered it properly, and so the question said, write but do not solve, so didn't solve anything, an equation involving one or more integrals whose solution gives the value of k, and this is the one that will do it. Okay, so that's part C, and okay, and that's it for question number 2.